Hello, my statistics students! Good to see you. I am recording a video to talk through number 1 from the section 3.5 CYU discussion. So this might end up being broken up into several videos depending on how long this goes, but I'm going to be writing on my tablet, so most of the time my head will be down. I will still make myself a little bubble in the corner in case I'm using my hands to talk through something, but just know that that's why I'm not looking at the camera up here. So let me go ahead and minimize myself. Okay. So here is this question. And originally this is the first, I'll say the slide that's kind of identifying what question we're on. So when I start making these PowerPoints, I'm going to make it in this way. And then I can post also the work from the PowerPoint along with the videos so that you have access to that. So this is the question we're talking through today with the box of cookies and things like this. You have chocolate cookies and butter cookies. And then it prompts you to draw a tree diagram and calculate some of these probabilities. So let's go ahead and start on part A here. All right, so in part A, it says draw the tree diagram, or it says draw the tree, but this tree diagram that represents the possibilities for the cookie selections. So I'm going to go ahead and come into, oh, one second, I have to, okay, I had to move some of my little markers around at the top of the screen there so I could actually change the colors. Okay, so we're looking at cookies and we have 3 chocolates. I'm going to use orange to represent those and 7 butter cookies. So I'll use green to represent those. Okay, so we randomly select a cookie and eat it. Then you randomly select another cookie and eat it. So when we talk about this eating, if y'all remember, this is the same concept of without replacement, meaning we aren't putting that cookie back in the, I'll say the box. So that will change the probability on the second trial. So that means that these trials are dependent. And maybe let's talk about how do we know that we have 2 trials in the first place. So what we're looking at here is a situation where we take 1 cookie and eat it. And so that would be trial 1. And then we take another cookie and eat it. And that would be trial 2. Both of these together form the event. So the event is 2 trials. So as an example, event A, which we usually use letters to represent events, capital letters. Event A would be as an example, an event that we eat a chocolate and then a butter cookie. So this is just an example of what an event might look like. Okay, so when we're drawing a tree diagram, what we're getting at is that each of the pathways on our tree diagram represents 1 event. In this case, we'd have 1 event with 2 trials for each of these. So if we come on in here, I'll use green to kind of start our diagram. Trials are going to correspond to, I'll say vertically, the different columns we're considering. So in our first trial, when we eat 1 cookie, we have 2 options that can happen. We can either eat a chocolate or we can eat, oh, I did use green, a butter cookie. Okay, I'm going to change my color on these so that that's not confusing. This is trial 1 and trial 2. So trials are in purple. Okay. So we start off with chocolate or butter. Then let's just assume we ate a chocolate one first, meaning we're looking at the C there. If we have a chocolate on the first trial, that means we could also have a chocolate on the second one. But if we had a butter cookie on the first one, that also means we could have a chocolate on the second one. Okay? Now, considering the other way, if we eat a chocolate on the first one, it's possible we eat a butter on the second one. If we eat a chocolate cookie on the first one, it's possible we eat a butter cookie on the second one. So here we have 2 trials. And again, what we're doing is noting, like in trial 1, what is possible. In trial 2, what is possible, but given that the trial 1 has already happened. And if you heard me carefully there, I said given trial 1 has happened. And that's also what's leaning into this dependent without replacement here, is that we're saying like given trial 1 happened, or given we've already eaten a cookie, for example. Okay, So let's kind of come down and calculate what's going on with these probabilities. So as an example with making these types of tree diagrams, if we consider this first event, so the first event, for example, would be going from here to here. Okay, so considering this chocolate route, let's even look back at the box that we have. So let's say on trial 1. So on trial 1, what is the probability that we choose chocolate and what is the probability that we choose a butter cookie? So the probability that we choose a chocolate, we have a total of 10 cookies and 3 of them are chocolate. So that probability would be 3 out of 10. The probability of butter cookie would be similarly 7 out of 10, meaning there are 7 ways to choose a butter cookie out of the 10. So that corresponds here, for example, that first chocolate, that would correspond to that 3 over 10. And then the first B, butter, would correspond to the 7 over 10. Okay, so now we're moving on to this second chocolate here. And the second chocolate itself, and I know I'm kind of skipping into other questions here because other questions ask you to write these probabilities, but I'm just kind of summarizing it as much as I can in one video. I know it's already 6 minutes. So this chocolate is not just saying what's the probability that we eat a chocolate. Again, this is assuming we have already eaten a chocolate cookie. That's what going down this path means. So we're looking at the probability that we eat a chocolate cookie on the second cookie, given we ate a chocolate cookie on the first cookie. So without going into the formulas, which I understand formulas are very helpful, but they can also be a little distracting or a little intimidating, or I'll say they make us lose some of our context for what we're actually looking at. So I want to think logically about the probability that we eat a chocolate on the second, given we've eaten a chocolate on the first. And I'm going to write this now as chocolate given chocolate, just because we understand that means this is trial 2 and this is trial 1. Okay, so the probability that we eat a chocolate on the second cookie, given we've already eaten a chocolate. I'm going to say that slowly again. So we've already eaten 1 cookie, which means we only have 9 cookies total left. It's gone. It's in my belly. So out of the 9 cookies left, how many are chocolate? And that depends on what happened on that first one. And in this case, I ate one of the chocolate ones. So instead of having 3 chocolate cookies left in that box, there's only 2 chocolate cookies now left. So the probability here that we eat a chocolate on the second one after we've eaten a chocolate on the first is 2 out of 9. So this probability is 2 out of 9. All right. So now to actually calculate the probability of that event, so going from chocolate to chocolate, this would be like looking at the probability of chocolate and chocolate. So that and is a clue that we're looking at multiplication. So we're looking at that both these trials happen, chocolate first and chocolate second. So because of that, what we're going to do is multiply these probabilities, and that's how we come up with the probabilities in these tree diagrams. So I'm just going to keep working down here. The probability of chocolate and chocolate would be the probability that we eat chocolate on the first times the probability that we eat chocolate on the second, given we've already eaten a chocolate cookie. Which means if I'm talking through it logically, I understand I just wrote the formula down, but the formula is using the logic I'm saying. So let's say we had a chocolate on the first one. Well, that probability was 3 out of 10. And now I want to multiply that probability with the probability that I eat one on the second one, which again, now we only have 2 chocolates out of 9. And so the probability that corresponds to this very top pathway on my tree diagram would end up being 6 out of 90. And I'll say for the sake of our class, I don't necessarily require you to simplify fractions. Of course you can. So here we could work on maybe dividing both numerator and denominator by 3, and we might have to keep simplifying after that. So if we divide by 3, we'd have 2 over 30. We can still simplify that. So divide by 2 again, we'd get 1 over 15, I believe, is equivalent to 6 over 90. Okay, So that would be that probability on that first one. I'm going to pause the video here. It's already 10 minutes. And then I'll start other videos to kind of talk through the other parts of the questions. Okay, give me 1 second.